video on word problems with rates, we saw how simple motion problems, which use the equation your rate times your time is equal to your distance, can be very similar to simple work problems, which use the equation rate times time is equal to work. There's a special subclass of work problems known as combined work problems or combined rate problems that have special versions of this rate times time equals work equation. And to understand where they come from, you first have to remember, what does rate stand for? Rate is a snapshot of the work someone gets done every unit of time for whatever you're measuring. So every hour or every day or every minute. For example, if I'm building a doghouse and it takes me 4 hours to build this doghouse, another way of writing that is every hour I get 1/4 of the job done. So if we envision a situation where I'm not building this doghouse alone, where I have a buddy helping me, and my buddy, if he were to do it by himself, his time would only be 3 hours. In other words, every hour he would get 1/3 of the job done. And then you could see if we were working together for 1 hour. In 1 hour, I would get 1/4 of the job done, and my buddy would get 1/3 of the job done. So if you wanted to calculate our rate, which again is a snapshot of how much we got done in 1 hour, you would have to say we're going to add 1/3 plus 1/4, which would give you 7/12. So every hour that my buddy and I work together, we get 7/12 of the job done. Once we know our rate, we could plug our rate back into our original rate times time equals work equation, or our rate of 7/12 times a time that we don't know yet would equal one job being done, or one house being completed. And then our time, we could figure out, would be equal to 12/7. So working together, it takes us 12/7 of 1 hour to complete the job. So there are two things that we could extract from this example. One is how we figured out our time when we combined our rates. The standard formula you use is your rate 1, your first rate, plus your second rate, just like we did when we added 1/3 plus 1/4. So rate 1 plus rate 2 times the time is going to be equal to your work. And then when you're talking about just one job being done, your rate is going to be equal to 1 over your time, and likewise your time is going to be equal to 1 over your rate. And that's why we figured our rate to be 7/12 and our time to be 12/7. When there's just one task being done, rate and time will always be the inverse of each other. So to sum up the equations you have to know for work, if you have one person or one machine doing a job, your equation is simple. It's your rate times your time is equal to your work. If you have two machines or two people working with different rates, you say the first rate plus the second rate. That gives you your combined rate. And you multiply your combined rate times the time, and that gives you the work being accomplished. Your rate is going to be equal to 1 over your time, and your time is going to be equal to 1 over your rate. There's one more equation that's less common but still appears, and that's when you have many machines and many people working, but they all have the same rate. If you have machines or people with the same rate, then your equation becomes the number of people or machines you have times the rate of each machine times the time they work, and that is going to be equal to the total work being done. So let's try a few together. Here we have a machine that takes 12 hours. That means we know the rate of the machine is going to be 1 over his time, or 1/12. Machine B has a time of 8 hours, or a rate of 1/8. Since they're working together, we're going to use the equation that rate 1 plus rate 2, parentheses, time the time, is going to be equal to the work being done, or 1/12 plus 1/8 times the time that we don't know is going to be equal to one job being done. Unless they specify how many jobs are being completed, you can usually assume that work is equal to 1, or one job being done. So now we add our fractions, we find a common denominator. So I'm going to rewrite this as 2 over 24 plus 3 over 24, and that's going to be equal to 5 over 24, and that's my rate. And to save time, I can simply remember that rate and time are inverses of each other, so my time must be equal to the upside down of that, or 24 over 5, which would be 4.8 hours. In this problem, we're comparing sets of boys, a group of 2 boys, and they're going to be joined by 3 other boys later. Since the problem doesn't tell us they have different rates, we can assume that each boy is working at the same speed. So we have multiple boys with the same speed, so we're going to use the equation that the number of boys we have times their rate times their time is equal to the work getting done. Starting off, we have 2 boys times a rate that we don't know times a time of 2 hours and 30 minutes. And to make my life simpler, I'm going to write everything in terms of minutes. So 2 hours, which is 120 minutes plus 30, so a time of 150 minutes, that's going to equal to the work being done. And in this case, we're only talking about 1 lawn being done, so it's 2 times r times 150 minutes is equal to 1 lawn being mowed. Or their rate is equal to 1 over 300, which means every boy, every minute, mows 1/300th of the lawn. So now we're going to add 3 other boys. So we have a total of 5 boys, but the rate hasn't changed. So our equation is 5 boys times the rate of 1 over 300 times the time that we don't know is equal to 1 lawn being mowed. 5 times 1 over 300, I could write that as 5 over 300, which simplifies down to 1 over 60. So my equation is 1 over 60 times time is equal to 1, or my time is equal to 60, or 60 minutes, which is 1 hour. Up until now, we've solved problems with everyone working together. Now we want to try and solve a problem figuring out how long it would take someone working alone. The easiest way to do these kinds of problems is to calculate everything in terms of rate. When they're working together, they can mow the lawn in 20 minutes, which means every minute they get 1/20th of the job done. When he works alone, Johnny can mow the lawn in 30 minutes, which means every minute he mows 1/30th of the lawn. So we could write the equation that every minute Johnny mows 1/30th. Then Bobby mows some portion that we don't know yet. And when we combine those 2 portions, they equal 1/20th of the lawn. Or Bobby's portion is equal to 1/20th minus 1/30th. We rewrite this with common denominators, and we get Bobby's portion is equal to 3 over 60 minus 2 over 60, giving us 1 over 60. And that's his rate. So if his rate is equal to 1 over 60, we know his time must be equal to the upside down of that, or 60 over 1, which, just like our last problem, ends up being exactly 1 hour.